Hello. In this lecture, we are going to make an introduction to brass instruments. The brass section is the most powerful section in the entire orchestra. They have great dynamic power and majestic sound. We are going to hear it in this example. But before we listen to the excerpt, I like to give some information. We have 4 horns in E. They will sound a minor sixth down. And then we have 3 trumpets in E. They will sound a major third up. We have 3 trombones and 1 tuba. You see, we write first and second horn in one staff, third and fourth horn in another staff, first and second trumpet in one staff, and the third trumpet alone in another staff. 2 trombones in one staff, the third trombone and the tuba share one staff. By the way, this is also the standard number of instruments in a traditional orchestra. 4 horns, 3 trumpets, 3 trombones, and 1 tuba. Doubling will be one of our main concerns in this section. Let's ignore the horns for a moment and take a look at the other instruments. We have a 4-voice texture here. We have 3 voices in the trumpets and then a bass line played by the second and third trombone. The first trombone and the tuba do not play until the end of the excerpt. We have the entire music in the trumpets and trombones, but we have also their doublings here. We can find everything in the trumpet parts also in the horns with some additional notes. If we look at the first horn, we will notice it is the doubling of the first trumpet, and the second horn plays in unison until that point, and then we have an additional tone. Let's take a look at the third horn. Third horn is at the beginning, the doubling of the second trumpet, but after that note, until that point, they are together. B flat E, E flat E. By the way, they will sound in octaves. Trumpets will sound a major third up, but the horns will sound minor sixth down. And after that, in the second trumpet, we have the same note as the one in the second horn, and then it remains in the horn, in the second horn. And at that point, the third horn plays the same notes as the ones in the third trumpet. And the fourth horn is a doubling of the third trumpet until that point, but after that it begins to double the melody line. First and fourth horns are playing in octaves now. So, how to distribute a chord to the brass instruments and what kind of effect we get from different instrumentations? We are going to talk about such topics in details in our following lectures. Let's have a listen. As we saw, we have 4 horns, 3 trumpets, 3 trombones, and 1 tuba in a standard orchestra. We have also cornets, euphoniums, Wagner tubas, and ophicleide, and many more. We can see them in historical scores or in brass bands, but today they are not members of a standard orchestra. Because of that, we are going to focus on these four instrument families. We make two kinds of division of the brass section. First, in terms of timbre, we have the horns on one side and the other brass instruments on the other side. The horns, the sound of the horns is much more softer and much more smoother, and they can be mixed very well with other instruments. On the other hand, we have trumpets, trombones, and tubas, whose sound is very brilliant, metallic, and overshadowing. If we use them in combination with other instruments, with woodwinds, for example, these brass instruments will overshadow the other instruments. In contrast to the horns can be combined very well with other instruments. The reason why they sound differently is their mouthpieces. This is the mouthpiece of horn, and you see it has a funnel shape without any edges. But if you look at the mouthpieces of other brass instruments, you will see they have cup shape and they have some edges. That means the air. If the player blow the air through the mouthpiece, the air goes directly in the mouthpiece, in the horn. But here we have some reflections, and the shape is not especially well, of course, but I'm sure you get the idea. We have some surfaces against which the air crash. Also here in the tuba, some surfaces in the way of the air. This fact changes the sound, the timbre of the instruments. The rule is the shallower the cup, the more brilliant the tone. And we see the cup of the trumpet is the most shallow, and the cup of the tuba is the less shallow. So the tone of the trumpet is the most brilliant, and the tone of the tuba is the less brilliant in this group. The other way of dividing the brass section is to do it in terms of transposition. We have transposing brass instruments, we have horns, trumpets, and cornets, and then we have non-transposing brass instruments, which are trombones, tubas, and euphoniums. You can ignore these ones, although the cornet, we can see the cornets also in the modern orchestras, but we don't. Euphonium is actually a tenor tuba, but we use today bass tubas. If you see tubas, they are bass tubas, and they are standard in our orchestras today. In this table, we can observe the transposed brass instruments. This section is horn section, and this section is the trumpet section. This is C alto horn. This is a non-transposing instrument, exactly like C trumpet. And all the other horns are transposed downwards. For example, if we see E horn, the sound is minor 6 lower. If we see G horn, the sound is perfect fourth, lower, etc. And some instruments are represented twice. For example, A. If you see A alto, it will sound minor third down. But if you see A basso, it will sound a minor 10th lower. That means for these four instruments, this indication also has to be given. Our standard horn today is F horn. In our orchestras, we have F horns. All the other instruments are historical instruments. We don't use them today. So, and our standard trumpet is B flat, although we also have C trumpets very often. This is an example of the placement of the instruments. The string section is always at the bottom, and the woodwind section is always at the top. And after that, we have the brass section. And between brass and string section, we have percussion and plucked instruments like harp and keyboard instruments like piano or celesta and so forth. There is also an order of individual instruments, exactly like in the woodwinds we have flute and then oboe, clarinet and bassoon. We have horns at the top of the section, and then comes the trumpets, trombones and tuba. We have to apply this order exactly. All the brass instruments, without an exception, produce sound through overblowing, which means they can only produce the harmonics, the overtones of a fundamental pitch. Let's say this is horn in C. Horn in C. Those are the only pitches that this horn can produce. That means this instrument cannot play a D2 or this note or this note or this B flat or this E, none of this. Also not F sharp, for example, here. Also the chromatic alterations, also not C sharp here. Those are not possible. Only the pitches which belong to the harmonic series of this C are possible in this instrument. This fact brings some problems. This is the harmonic series of C1, and you see some pitches do not correspond to our well-tempered tuning. Those are the values of deviation in cents. This one is 31 cents, as you know. 100 cents correspond to 1 half tone. So this means a third of a half tone, and this one is the half of a half tone. That means this is a quarter tone. This pitch, F sharp, is exactly between F and F sharp. That makes some pitches in this harmonic series useless. This one, for example, this one, and those ones. But we are going to see there are some techniques with which the players can adjust the intonation and make those pitches usable. We do not need this practice today because we have a very elaborated mechanism which I'm going to explain in a couple slides later. But in the old times, when this mechanism didn't exist yet, the player had to find solutions to make those tones usable. Otherwise, it would have been too much limitation. This is an example from the literature from Britain. A 20th century composer, actually. In the 20th century, we had modern instruments with valve mechanism, which I'm going to explain later. He requested on purpose some pitches from the harmonic series of C. This is a horn in F. That means it will sound a fifth lower. But the principle doesn't change. Every instrument, the sound changes. For example, if we say this is E flat horn, then it would sound major sextum. If we say this is B flat basso or alto, it will sound a major ninth lower, etc. But the notation is always based on C, the harmonics on C. I'm talking about historical practice. And in this excerpt, Britten requested natural tones from the harmonic series without any change in the intonation. We are going to hear that those tones marked with an X will sound lower than our equally tempered tuning system. Let's listen to it. This F sounded 51 cents higher. You see here 49 cents lower because it is written as F sharp. It doesn't matter actually because it is exactly between F and F sharp, the sound. So, and this B flat sounded 31 cents lower, and this A sounded the same situation, minus 59 cents. It is here plus 41 because it is demonstrated as A flat, but here it is A natural. It is almost in the middle of A flat and A natural. This is another example from Baroque literature, from Bach Brandenburg Concerto. You will hear this line very clearly, although we have the same situation. We will hear those notes. We will hear A, which is also problematic. B could be okay. But then we have also F natural here, which is also problematic. Also, this pitch is problematic. It is actually much lower. But the instrumentalists in that time, in that era, were very good at correcting the intonation with their lips and with their breath. And the hornists did it also with their hands. They put their hands in the instrument in order to adjust the intonation. Let's have a listen. Although we hear some problems in the intonation, I think that was a modern instrument because it is not possible in a historical instrument to play this line as clear as we heard just now. If you listen to a historical performance of this work and of any other Baroque work, you will be surprised of many intonation problems. This is another example from classical era, this time from Mozart Symphony number 40. This is G horn. That means it will sound a perfect fourth lower. And in this passage, the only pitch which is problematic is actually this one, this F. This is here. In this case, it would sound 51 cents higher. The player should correct the intonation approximately a quarter tone lower. Let's listen to it. Another example is from Beethoven, from Piano Concerto number 5. And also in this example, we have only one problematic pitch, which is F5. Let's have a listen. By the way, those intervals, the succession of these intervals, fifth, perfect fifth, then major third, perfect fifth, and minor sixth, those are called horn intervals because of the fact that they can only play the harmonic series. It was very common to use them in this succession with this combination, and those intervals became a very characteristic feature of Western art music, especially in the classical era. This is another example by Beethoven, Symphony number 3, and we see here some problematic F5 in a very high register in A. B would be okay, but this is a problematic pitch. Let's listen to it. Those performances are not especially realistic because they are modern instruments. With historical instruments, the passages would sound completely differently. The brass instruments have an interesting history, an interesting development process. First, let's clear the fact. We write something for a horn, it could be any kind of horn. The notation is always on C. The notation doesn't change. I'm speaking about historical instruments. The composers wrote always the harmonics of C, no matter what kind of horn they used. They always wrote the harmonic series of C. But the sound will be different in each instrument. In F horn, it will sound a perfect fifth lower. In E flat horn, it will sound a major sixth lower. And in G horn, it will sound a perfect fourth lower, etc. So, that means in the classical era, for example, or in the Baroque era, if the piece was in A major, then the composer used horn in A. If the piece was in E major, then the composer used horn in E. That means for each key there was a specialized horn. This is a horn from the classical era. As you see, this is a long tube in spiral form. And what kind of horn it was depended on its length. The longer the tube, the lower the fundamental pitch. Imagine that every player or every orchestra had to own all different kinds of horns because they couldn't know which one was going to be needed in a particular piece. And imagine during a concert, there's a piece, a symphony in F major. Okay, we need a horn in F, but the second movement is in A minor. So we need a different kind of horn. The third movement is in D minor or C major. So we need a different kind of horn. It was very difficult in the praxis. So by the time of Haydn, people got the idea. They said, if it depends on the length of the tube, then maybe we can make only an addition here. We can add a couple of centimeters and then make the tube longer. And so we don't have to have the entire instrument in every possible sizes. It would be enough that we own only different size of these additional pieces. So, and they did this. This is next step. And you see in the next picture clearer, this is a crook. We call it a crook. This is an addition. This is a horn itself, the instrument itself, and this is an addition placed between the mouthpiece and the instrument. So that was a very practical invention for that time. It was enough to own only the crooks. Let's say this is for E flat horn, and this is for F horn, and this is for A. So the piece is in A major. Okay, let's take this piece and connect it to the instrument. The second movement is in F major. Let's take this crook and connect it to the instrument. That was very practical. This is a very unpractical thing for us today, of course, but for that time it was a very practical invention. Then people got another brilliant idea, and they said, okay, we want to extend or shorten the tube. Then we can build a mechanism which allow us to activate different sizes of tubes. And this is our modern horn. As you see, this is a horn, and we have some different tube lengths here. This is one tube length, this is longer, and then we have a shorter one here, then we have a little longer here, and then longer here, etc. So, and this is our valve mechanism. That was a great invention in the history. By using these valves, we are able to activate different sizes of tubes. So technically we have, let's say this is F horn and this is F horn. With this valve we have an E flat horn, and with this one we have an E horn. If we combine them, we have a D horn. I'm going to explain the mechanism. And here with this valve we have also D horn. If we combine those two, we have a C sharp horn. If we combine this one and this one, we have C, a horn in C. And if we combine all three, we have a B horn. Very interesting mechanism. That means we have access to all the partials of these fundamental pitches. If I produce this pitch, C5, without pressing any valves, then I would get this pitch by pressing the first valve. The first valve lowered the sound a major second. The second valve lowered the sound a minor second. The third valve lowered the sound, like in this case, a minor third, but also the first and second valves together do the same job. Both options will lower the sound a minor third. Then the combination, if I combine the second one with the third one, then I get a major third, lowering. If I combine the first one with the third one, then I will get a perfect fourth, lower sound. If I combine all the three, then I will get a tritone. And that's it actually. So I have access to the entire chromatic scale. This is a demonstration of the harmonic series of each fundamental tone. This is without pressing any valve. The fundamental pitch is C and I get only those pitches, only the harmonic series of C1. If I press the second valve, then I will lower the fundamental pitch a minor second. Then I will get the harmonic series of B0. If I press the first valve alone, then I will lower the fundamental pitch a major second and I will get the harmonic series of B flat. So if I press the third valve or if I combine the first and second valves, then I will lower the sound a minor third and I will get the harmonics of A. So, and if I combine the second and third valves, I will get the harmonics of A flat. If I combine the first and third valves, I will get the harmonics of G. If I combine all three valves, I will get the harmonics of F sharp. So, in total, I have access to the entire chromatic scale. You see, for example, I'd like to play B flat. It is not a good option here because it will give a problematic intonation. But if I press the first valve, I can produce a very clear sound. Here it is 1, 2, 3, 4, 5, 6, 7th harmonic, but here it is the 8th harmonic. I have the same note also here as the 9th harmonic, and I have it also here, but this is also not an optimal option. So, in this case, the horn player has two options to play B flat 4, either with first valve or with the combination of second and third valves as the 9th harmonics. And this is how our modern horns today work. Our modern horns are in F, but actually they are double horns, which means they are at the same time horns in F and also horns in B flat. Horn in F will sound a perfect fifth lower, and horn in B flat will sound a major second lower. But you don't have to care about it. You will write everything in F. Everything you write will sound a perfect fifth lower. The horn player will do the rest. This transposition, you can ignore it. This is just a mechanism in order to make the playing easier for the hornist. Otherwise, he can play everything here. This is only the mechanism of the F horn. He can play everything here, but with an additional B flat horn, and the switch mechanism is here. This is the switch between, we have three valves here, and a mechanism which switched between F and B flat horn. But you don't have to care about it. This is the job of the horn player. you also don't have to care about those harmonics unless you want a special effect, like Benjamin Britten did in our example. Benjamin Britten wanted the natural pitches on purpose. Many contemporary composers do that. They request the natural pitches, they indicate exactly the valves and harmonic number. So unless you want to get an effect, you don't have to care about this mechanism, but still you have to know how the instrument works. The same is also true for the trumpet. You see here, this is the overtone series for the modern trumpet, and this is this overtone series for the old natural trumpet. The difference is that the modern trumpet cannot play the fundamental, also cannot play the first and second overtones. It begins with the third overtone or with the fourth partial. But the old natural trumpet can play the third partial. If you apply our valve mechanism on the trumpet, that means we can lower this pitch a tritone. Remember how they work. The second valve, the second valve, the first valve, the third valve, and with their combinations we can get this note a tritone lower, F sharp. And you see here this is the lower limit for the trumpet, and the higher limits are not especially strict. Actually, it depends on the player, but generally you shouldn't go higher than this pitch. This is still very high. Actually, this should be your limit, C6. And this is the notation, and the trumpet will sound differently in every size. This is trumpet in A, the sound will be D sharp. This is trumpet in B flat, the sound will be E. And the trumpet in C, there's no change, of course. And the trombone. Trombone is one of the most interesting instruments in the orchestra because it is surprising actually. You wouldn't expect that, but it is the instrument which completed its development already in the 15th century. It is very interesting. We had the same trombone, exactly the same trombone, the same instrument, also in the 15th century. We don't have any other example of the situation because every instrument is different. If you look at a Baroque violin or Baroque flute, clarinet didn't exist in the Baroque time. And the other instruments are very different in the old times, except for trombone, it was exactly the same. As you know, the trombone doesn't have a valve mechanism. Instead of this, it has a slide, which does the same job actually. It makes the tube longer or shorter. So, and we have 7 different positions, each of which gives a different fundamental pitch. The first position will give B flat, the second position will give A flat, G, and chromatically until E, between B flat and E. As you probably expect, we have only the harmonic series of the individual pitches. In the first position, we can only play the harmonic series of B flat. We cannot play E natural, for example, because it is not a member of the harmonic series of B flat. But we can play E natural here because it is a member of the harmonic series of A. So, but here we cannot play E flat, but we can play E flat here in the third position, etc. And this is the table. Let's take a look at this part. I will explain the other part in a couple of seconds. In this part, you see this is first position and the fundamental pitch is B flat, and we can get only the harmonics of B flat. In the second position, I have the partials of A, and here the partials of A flat, etc. We have many chromatic tones here, but we have also a couple of problems. The first problem is that we don't have the pitches between E. Those fundamentals cannot be played by the trombone. This is the lowest pitch here, and then we have a tritone leap. And the next pitch we can play is this B flat. We don't have B natural, we don't have C, we don't have C sharp in this register. That was one problem, and the other problem is if you ever observed a trombone player while playing, you will notice the motion of his hand. In the first position, his hand is very close to his body. And in the seventh position, his hand is far away from his body. So keep this fact in your mind. Let's say I want to hear this pitch, B flat here, and then I want to hear B natural. Where is the B natural? It is here, in the seventh position. So, his hand should move from here to here in order to produce a half-tone movement. If the passage is in a fast tempo or if the notes have short durations, then it would be impossible to play. So, for this reason, people developed another mechanism. Similar to the horns, they built a switch mechanism which makes everything in this part a perfect fourth lower. In the first position now, we have F, but we don't have the fundamental because they cannot play it, the fundamental, like in this case. But the fundamental is a perfect fourth lower than this one actually. Then we have access to the harmonics of F. In the second position, we have the harmonics of E, etc. And notice we have only 6 positions because the lower it goes, the larger will be the distance between the pitches within the fundamentals. Here the distance, let's say this is 1 meter. We have 7 semitones, 7 half tones within 1 meter, but here we have only 6 half tones within 1 meter. So, and with this mechanism, now we can play almost every chromatic pitches. Let's take the same example. I have this B flat, and I want to play B natural in this octave. It is right here in the second position now. I don't have to go to the seventh position, only one position different. I have to press the switch. It is called F switch. I have to press F switch and then I'm in this part. But still, if you look at the pitches, I have all the chromatic tones here. F, E, E flat, D, C sharp, C natural, B flat. I don't have B natural in this register. Be careful not to write B natural in this register because it doesn't exist in the trombone. There is a particular mechanism only to produce this pitch, this B natural in this register, but not every instrument has this mechanism. So do not write B natural in this register. As you probably know, glissando is a very typical playing technique for the trombone, very characteristic, but not every glissando is possible on the trombone. So you always have to have this table in front of you if you want to write a glissando. The tones of glissandi have to be the same partials. For example, this F is the sixth partial. We can make a glissando between F and C sharp here. This is also the sixth partial of F sharp. But we cannot make a glissando from F to this G, for example, or I don't know, this B natural. We cannot switch to another partial. They have to be the same partials. Let's talk about these examples. The first one, C sharp and G sharp. Is this glissando possible? Let's check it. We have a C sharp here. This is the fifth partial. And then we have the G sharp here. This is also the sixth partial. That means yes, we can do this glissando. What about the next one? Between B and G in this register, we have B here. Let's clear the picture. We have B here, but we don't have a G. And it is not possible to take the G as another partial. And what about if I use the F switch? Let's check it. I have a B natural here. Then G here, yes. I can do this glissando with F switch because B natural is the sixth partial and this G is also sixth partial. Then I can do it with F attachment. But the problem is, although this instrument with F switch, our standard instruments today in the orchestras, there are still some trombone players which only have this part without F switch. The reason is that the trombone sounds better without F switch. And the instruments which have only this part are called tenor trombones. And the instruments which have both parts are called bass trombones. Bass trombones are a little larger than tenor trombones, and tenor trombones which have both parts are called tenor bass trombones. So if you write this glissando, then make sure you indicated that you want tenor bass trombone, not tenor trombone, tenor bass trombone. The same is true for the bass trombone. In bass trombone, this part sounds better than tenor bass trombone, and in the tenor trombone, this part sounds better than tenor bass trombone. Tenor bass trombone has a practical advantage, but in sound quality, it is not especially bad, maybe even not noticeable at all, but if it is about perfection, there's a difference between them. Let's check the last one. A glissando between A and C sharp. A is here, but we don't have a C sharp here. We have C sharp here, but this is a different partial. That was the second partial, but this one is third partial, and we don't have A here. What about the other part? C sharp We have one C sharp here, but once again we don't have A here. As you see, this glissando is not possible on the trombone. So, if you write any glissandi for the trombone, always have this table in front of you and always check if it is possible. This is an overview of the ranges of the instruments. We have horn. This is the notation. This is the only thing you should consider. Beginning with F sharp, it is also possible with B flat division, as I mentioned, the switch, B flat switch, to play those notes, but they are too low. Begin with this F sharp, and this is also too high. Maybe it is better to stay here if there's not a particular reason for that. So, and then for the trumpet, as I said, the notation is this, from F sharp to D, or I recommend to C. And the sound will be different in every instrument. And then we have tenor trombone without F switch, that means without F switch. And it begins here, and then we have some pedal tones, and then we have a gap between B flat and E. And then we have bass trombone, and it begins with this B natural and goes to the B flat here. And the upper limits are not fixed, they depend on the player. And we have a tenor bass trombone, which is our standard instrument. But you should always indicate that you want to have a tenor bass trombone. Otherwise, you cannot be sure. It could also be only the tenor trombone, only the left-hand side of the table. And then we have euphonium. This is tenor tuba, but you can forget about it. It is not used today. This is our standard tuba, and this is its range. By the way, you see here in F, the instrument is in F, but it is not a transposed instrument. We have two kinds of bass tuba, one in F and one in E flat. In our orchestras is this one, standard, but you can find this one in brass bands. But this is not a transposed instrument. This is just an information, a construction information. You have to write what you want to hear, and this is the sound. This will be the sound. You can also forget about the following ones. They are also not used in our orchestras. I'd like to talk shortly about some common characteristics and effects on all brass instruments, beginning with attacks and tonguing. Sforzando and fortepiano, those accents are very effective in the brass instruments, much more effective than any other instruments of the orchestra. Let's listen to this passage. A very characteristic feature of brass instruments. And then we have some tonguings, light, soft, and fast tonguing. An example for that by Debussy from Je. Let's listen to it. Then we have double tonguing in fast passages, like here. And it is produced through the syllables tuku or teke. Let's listen to it. The excerpt is from Ravel's Rhapsody Espagnole. This could also be played through single tonguing, of course, because the tempo is not extremely fast. We have also triple tonguing. It is produced through the syllables tukutu or tutuku or tekete or teteke. Let's listen to it. The excerpt is from Rimsky-Korsakov's Shehrazad. To play this passage through single tonguing wouldn't be possible. And then we have another very characteristic tonguing, flutter tonguing. So, it is also used in woodwinds, especially in the flute. They are also very characteristic for the brass instrument. This is an excerpt from Richard Strauss' Don Quixote. Let's listen to it. And the glissando. Actually, the real glissando can be made only by the trombones through slide. But you see also here glissandi for the other instruments, for the horns, for the trumpets, and for the tuba. This one is tuba. They are not real glissandi. They are chromatic glissandi. They play, for example, the first trumpet begins with B here and make a fast chromatic scale until the one octave higher B. And this is true for all the other instruments. This one is chromatic glissando, but there is also another kind of glissando, especially typical for the horn, which is called harmonic glissando. And that means begin with one tone, let's say with C, and play the harmonics of C until that G, for example. But it has to be indicated harmonics glissando. In this case, this is a fast chromatic scale. Let's listen to it. And finally, we have many mutes for the brass instruments. They are a very important part of the brass music. The string instruments are the richest instruments in terms of playing techniques. We have many different kinds of playing techniques. We can play sulponcello, sultasto, we can play pizzicato, we can play col legno. We have many means to change the sound. Woodwinds, for example, they are very limited with the playing techniques. They have a particular timbre and we cannot change them especially much. It is also true for the brass instruments, but we have excellent devices in brass music which we call mutes. All brass instruments can be muted in contrast to the woodwinds. Muting can create a pianissimo, of course, but this is not their actual purpose. They can reduce the volume, but the real purpose of the mutes is to change the character or color of the sound. This is the important part. And I strongly encourage you to experiment with different mutes. You will be surprised how many different sounds you can get from these instruments. So this is a passage from Vaughan Williams Symphony No. 6. And you see here consordino. This is how we indicate a muted passage. But it is not indicated what kind of sordino, what kind of mute. We are going to see we have lots of mutes, very different kinds of mutes, and each of them produce a completely different kind of sound. If it is not indicated, that means this is the straight mute. This is the most common mute in the repertoire. Let's listen to it. Without any reference sound, it is of course not clearly noticeable the difference between a muted sound and an unmuted sound. And we have many different kinds of mutes. As I said, this is the most common one, straight mute. And we have cup mute. And then we have harmon or wah-wah mute. Actually, they are the same. It is the same mute. It has a stem in the middle of the device. If you remove the stem, the sound will be very deep and melancholic. With stem in, we can get a wah-wah effect by opening or closing the opening of the mute. And then whisper mute, solotone mute, bucket mute. We also have other possibilities to mute the instruments. We have a device called plunger. It is not a mute because it is not put in the instrument. It is held in the hand instead. And then we have a device called hot or derby. We can also put the hand over the bell or in the bell. And another possibility is playing into the stand and inserting a cloth or handkerchief in the bell. Those are other creative possibilities of changing the sound. Giving an example for each of them would be beyond the scope of this lecture. You can find many videos which demonstrate the sound of different mutes. I strongly recommend to watch them and experiment with different kinds of mutes in your orchestration assignments and also in your own compositions. So that's all for this lecture. Thank you for watching and I'll see you in the next lecture.